The first step in the BGP route selection process is to prefer a route with the higher local preference value. The local preference value is simply a numerical value that a network operator in the local AS can assign to a particular route. This attribute is purely local. It does not get transmitted between autonomous systems, so it is dropped in eBGP route advertisements, but it allows a local network operator the ability to explicitly state that one route should be preferred over the other. Among routes with equally high local preference values, BGP prefers routes with shorter AS path length. The idea is that a path might be better if it traverses a fewer number of autonomous systems. The third step involves comparison of multiple routes advertised from the same autonomous system. The multi-exit discriminator value allows one AS to specify that one exit point in the network is more preferred than another. So lower MED values are preferred, but this step only applies to compare routes that are advertised from the same autonomous system. Because the neighboring AS sets the MED value on routes that it advertises to a neighbor, MED values are not inherently comparable across routes advertised from different ASs. Therefore, this step only applies to routes advertised from the same AS. Fourth, BGP-speaking routers inside an autonomous system will prefer a BGP route with a shorter IGP path cost to the IGP next hop. The idea here is that if a router inside an autonomous system learns two routes via IBGP, then it wants to prefer the one that results in the shortest path to the exit of the network. This behavior results in what is called hot potato routing, where an autonomous system sends traffic to the neighboring autonomous system via a path that traverses as little of its own network as possible. Finally, if there are still multiple routes with the highest possible local preference, the shortest AS path, and the shortest IGP path, the router uses a tiebreak to pick a single best route. This tiebreaking step is arbitrary. It might be the most stable or the route that's been advertised the longest, but often to induce determinism, operators typically prefer that this tiebreaking step is performed based on the route advertisement from the router with the lowest router ID, which is typically the neighboring router's IP address. Let's now take a closer look into local preference, AS path length, multi-exit discriminator, and hot potato routing. Now, as I mentioned, the first step in the route selection process is for routers to prefer routes with higher local preference values. Now, an operator can actually set the local preference value on incoming BGP route advertisements to affect which route a router ultimately selects. Let's see how this works.